So what we have in question 6.4 is we have a man who starts off at the ground level of a shopping centre. So let's call this a height of 0 metres. And then what he does is he hops onto a set of escalators, and those escalators take him up to the first floor, and the first floor is a height h, which is equal to 4.6 metres above ground level. So while he's on the escalators, he undergoes a displacement which might look something like that. And while he's on those escalators, he gets acted on by a couple of forces, one of which is the gravitational force, which acts on him straight down. He also gets acted on by the escalator, which moves him upwards. And the escalator will also exert a normal force on him perpendicularly as well. But what we need to figure out is what is the work being done on the man by the gravity force. And probably the easiest way to figure out that is to say, well, the work that gets done by the gravitational force on an object is going to be equal to the negative of the change in that object's gravitational potential energy. So that's going to be equal to the negative of the object's final gravitational potential energy minus the object's initial gravitational potential energy. So let me just label this up. This is going to be final GPE, and this is initial GPE. And here, since we choose our reference point to be ground level, that just has a height of 0, so his initial gravitational potential energy will be nothing relative to this reference point, and his final gravitational potential energy will just be his mass times g times whatever this height is. So the work being done by gravity is going to be equal to mgh minus 0 is equal to minus the guy's mass times g times h. So we can write that the man's mass is equal to 75 kilograms. And so the work being done on him by gravity has got to be (75 times 9.8 times 4.6). It's going to be minus 3,381 joules. And in the second part, we want to know what the work being done on him by the escalator was. So really, there are only two forces which can do work on this guy, if we ignore air resistance. There's going to be the gravity force, which does this amount of work on him, and we also have the escalator, which is moving him upwards and doing work on him that way as well. So the total work in that case, we could say that the net work is equal to the work being done by gravity plus the work being done by the escalator. And by the work kinetic energy theorem, so we say by the work kinetic energy theorem, the net work being done on the man has got to be equal to his the change in his kinetic energy. This is change in man's kinetic energy. But what else are we told? We are also told that the man moves at constant velocity. So that means he had the same velocity before this work was done as he did after the work was done. So the total net work didn't produce any change in kinetic energy, which means that the total work being done on the man was just 0. So, but, we can say, but, since the man velocity was constant, that means that his kinetic energy was constant. That means the change in his kinetic energy was just 0. And thus, the work being done by gravity plus the work getting done by the escalator is just equal to 0 if we plug it into this work kinetic energy theorem. So we have that the work done by gravity plus the work being done by the escalator is equal to 0. And so the work that gets done by the escalator then is just going to be equal to the negative of the work that gets done by gravity. And so that's going to be 3,381 joules.